Hello, for today's lesson is all about electron configuration. At the end of this video, we are going to understand this example, the electron configuration of a chlorine atom. Now, let's recall our previous lesson about the atomic structure. This is how we illustrate chlorine atom. Remember our performance task A1, the atomic dream catcher? This is how your output looks like, right? Since the atomic number of chlorine is 17, so it has 3 shells, or also called as energy level. The energy level is up to 3, 1, 2, 3. Now, this electron configuration is another way to represent the distribution of electrons that are arranged in shells and subshells. New term is subshell. Subshells are paths of electrons in different shape. These subshells are named as S, P, D, or F. So we have S subshell, B subshell, P subshell, D subshell, F subshell. And this subshell has different maximum number of electron present. In this example, wala tay F subshell kay 17 raman ang atong atomic number ni chlorine. Now, let's discuss how many subshell in each shell, and also how many or what's the maximum number of electrons per subshell. On the first energy level, we have S subshell only, and S subshell can contain 2 electrons, maximum of 2 electrons. On the second layer, we have S subshell and P subshell, and the maximum number of electrons present in the P subshell, we have 6. And for the third energy level, we have S, P, and D subshell. Maximum number of electrons that D subshell can hold is 10. Now, if we recall in our previous discussion, we know that maximum electrons for the first layer is 2, for the second is 8 and 18. Let's review that one later. So still, the same ra gihapon, no? For the third energy level, we know 18 ang maximum electrons present. If i-add nato siya, 2 plus 6, that is 8, plus 10, that is 18. Now, if we are to illustrate the electron configuration of chlorine using the SPDF notation method or the orbital diagram, this is how we illustrate them. For the first shell, take note, we have only S subshell, and the exponent would be the number of electrons. The coefficient will be the number of shell or energy level. That's why 1s2, 2s2, 2p6. And on the third, we have 3s2. Let's get the total or the sum of our electrons from here to 3s2. Let's have 2 plus 2, that's 4. Plus 6, that's 10. Plus 2, 12. And we have the atomic number for chlorine is only 17. Therefore, what's left is 5. That is 3p5. Now, though the maximum electrons of P subshell kay 6, since 17 man ang atong atomic number, that's why 5 na lang siya para the total would be 17. Now, for the orbital diagram, this is how we illustrate 1, 2, arrow up, then arrow down, 2s2. For 2p, we know 6 electrons represented no by arrows, arrow up and arrow down. 1, 2, 3. This is how we write down the electrons. 1, 2, 3, 4, 5, 6, 3s, 1, 2, and 1, 2, 3, 4, 5. Okay, after my discussion, you will understand everything about this example. This time, let's review about how we get the maximum number of electrons per shell. So the formula is 2n squared, and if we are to illustrate the atomic structure of an atom, this is how we illustrate using the Bohr's model. 2n squared is the formula. N is the number of shell or energy level. If n is 1, that's 1 times 1 times 2, that is 2. When the energy level is 2, n is 2. 2 times 2, that's 4, times 2, that's 8. When the energy level is 3, that's 3 times 3, 9, times 2, 18, and so on and so forth. That's how we get the maximum number of electrons. And take note, orbits closest to the nucleus fill first. Yes, an electron will always enter the orbital with the lowest energy level. So, energy level 1 compared to energy level 5, mas higher yun siya no og energy level. So, closest nga shell closest to the nucleus have the lowest energy level. And also, another guidelines for in determining the electron configuration of an element, electrons will fill an S subshell first before filling the P subshell. Electron configuration can be written in SPDF notation or orbital diagram. SPDF notation is guided by Aufbau principle, and this is what we called SPDF notation. How did we get this pattern? Through this illustration. Note, in every shell we have, in the first shell we have only subshell, S subshell. On the second, 2 S and P subshell, and these are the maximum number of electrons per subshell. Third subshell we have S, P, D subshell, and the fourth SPDF, and then still the same, and SPD. So mo ni ang pattern para makuha nato ni nga SPDF notation. And the order would be dili siya by row but slanting from upper right to lower left. So take note, 1S, next is 2S, next would be 2P and 3S, turn, and 3P, 4S, 3D, 4P, 5S, 4D, 5B, 6S. So, mo na siya yahang direction. And then, we can come up with this SPDF notation. Next method is orbital diagram. The orbital diagram is another representation of how electrons occupy the orbitals or subshell. Now, for orbital diagram, representation niya for the electron is this arrow up and arrow down, or arrows. For the subshell, represented by boxes. Sometimes, kuandra siya, horizontal line. So, 3 horizontal line for the P subshell. S subshell has 1 box. P subshell represented by 3 boxes. D subshell this time kay represented by 5 boxes, and F subshell is represented by 7 boxes. So ang number of boxes kay kumbaga half ra no murag iyang pattern, half ra siya sa number of electrons nga ma-hold sa atong subshell. Let's observe 2 yung maximum electron, 1 boxes. Divide 2 ra yun siya para ma-identify nato pila ka boxes per subshell. Okay, let's have an example. Write the electron configuration of the following elements in orbital diagram and in SPDF notation. So we are going to supply or complete the table. But before that, let me share this technique para masayo nato ma-identify nga asa takotob sa atong SPDF notation. Now, this is the pattern. Okay, especially for SPDF notation, know that if ang atong atomic number kay 10, atomic number of the element is 10, therefore kutobrata sa 2p. That is 2 plus 2 plus 6 is 10. And if the atomic number is 20, kutobrata sa 4s. So that is 4s2 kay 10 plus 2, that's 12, plus 6. Maximum number of electrons akong giminan niya, plus 6, that's 18, plus 2, 20. If the atomic number is 38, kutobrata sa 5s. Because 20 plus 10 plus 6, that is 36, plus 2, 38. And if the atomic number is 56, up to 6s. And so on and so forth. Up to kung 7p, that's 118. Muna akong naalantay nga nga pattern para we know asa ta kutob mo stop. Especially sa orbital diagram po, magamit nato, no? Pila ka boxes tanan. Okay, let's have the first element, aluminum, wherein it has 13, or the atomic number is 13. Z is the symbol for atomic number. Since 13 man class, therefore, kutob ta sa 3p. Okay? Kay 3s, that's 12. Therefore, kutob ta sa 3p. Now, 3p, ang iyang boxes. For 1s, we have 1 box. For second energy level, we have S subshell and P subshell. That is 1 box and 3 boxes. And for the third energy level, or ika-third nga shell, we have S and P boxes. So, 1 box and 6 boxes. Now, observe how we input or write down the electrons, which is the arrows. Arrow up, arrow down, gina class, per subshell. So, 1, 2, 3, 4, and always put first the arrow up before arrow down, no, per subshell. That's 5, 6, 7, 8, 9, 10, 11, 12, and 13. We have now the orbital diagram. Let's have the SPDF notation. I guess dali na lang ang SPDF notation, no? Especially kung mag-base na lang ta sa orbital diagram. Okay, 1s input and then 2, 2s2, 2p6, 3s2, 3p1. Okay, let's proceed to the second example. We have calcium. The atomic number is 20. So, 20, therefore, exactly 20, kutob ta sa 4s. Let's have the orbital diagram. 1s, we have 1 box, 2s, 2p, 3 boxes, 3s, 1 box, 3p still, 3 boxes, and 4s. This time, let's put our electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. The SPDF notation would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. No? Sayo na lang kayo basta naata. Especially if inyo yung butangan daan tanan class. This is 2, this is 4, this is 10, this is 12. Para dali na lang yun ninyo i-ma-identify asa kutob inyong configuration. Let's proceed to the third element, chromium, having 24, or the atomic number is 24. Now, for this example class is nanasad tayo additional nga i-take note since in every rule na amang yun na siya exception. Since 24 ang atomic number, so therefore, kutob ta sa 3D. Okay, 3D kay 4s is 20 man. Let's have the orbital diagram. 1s, 2s, 2p, 3s, 3p, and 4s. And the last is 3D. Let's input the electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this is the expected orbital diagram. But in every ruling, there's always an exception. And the exception here, class, is bawal. Mura ni ang highlight. Mura ni ang need ninyong i-take note good. Always remember, sa electron configuration, dili pwede or as observed, never siya nga ma-D4 or D9. Why? Explanation ana, class, is the stability of the element. Stable ang element once half-filled, iyahang subshell, or fully filled. Now, half-filled sa D subshell is 5. Fully filled sa D subshell is 10, no? Kay maximum niya. The same sa, not just the D subshell, the same sa F subshell. Half-filled sa F subshell is 7. Fully filled is 14, right? Kay maximum number of electrons sa F subshell is 14. So, ang i-take note na nato, class, is dili ta pwede mag D4 and D9. Dili po ta pwede mag F6 and F13. Make it half-filled yun or fully filled. So, therefore, in this chromium, in this element, this will be the electron configuration or the orbital diagram. D5, instead of D4 as expected, make it D5. Kay bawal D4. And 4s1 na lang siya. So, this is the SPDF notation. 4s1, 3d5. Let's have another example. Copper, it has 29, no? Atomic number. Therefore, still kutob ta sa 3d. Kay maximum niya is 30, no? Total niya tanan is 30 and we have 29. So, the same na taog orbital diagram sa atong sa third example. Pero mag-differ sa number of electrons. So, let's input the electrons. 1, 2. Okay. So, 3p up to 3p, no? That is 18. 18 na ni. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So, supposedly, this is the orbital diagram of copper. But, again, observe 3d9. And the exception sa ruling is dili pwede, no, as observe nga 3d9, 3d10, or d4 rather, and d9. Therefore, the orbital diagram for copper would be fully filled siya before mo enter si electron sa ika-fourth nga energy level. Again, please don't forget, never ta or dili pwede ang D4 and D9 for D subshell, and never pod or dili pwede ang F6 and F13 for F subshell. Make it half-filled or fully filled. We have here the last column, which is all about magnetic properties. Magnetic properties of an element can be paramagnetism or diamagnetism. When we say paramagnetism, it is defined as the characteristic of an element to be attracted to a magnet. So, the opposite one is the diamagnetism, wherein characterized by non-attraction to a magnet. And paramagnetism and diamagnetism can be easily identified if we have the orbital diagram of an element, because paramagnetism siya or ma-attract ang element sa magnet if naa siya unpaired electrons. Paramagnetism if naay unpaired electrons ang element. So, example number 1, which is the aluminum, is considered paramagnetism kay naa may single nga element. Second example, which is the calcium, is under diamagnetism since wala man siya unpaired electrons or walay single, no? Na ay couple tanan, sana all. Therefore, dili siya mo-attract sa magnet. Next is the SPDF blocks of periodic table. This is the arrangement po no based sa ilang electron configuration wherein ang group 1 or the first and second column, group 1 and group 2, ends their electron configuration ends with S subshell. So probably here is 2s1, 3s1, 4s2, 5s2, and for the transition metal, mostly no transition metal man dire kay D subshell. For D1, D2, ingana tingali, and for the last row, 7D. D subshell ilahang N sa configuration, and here P subshell and F subshell, 5F subshell. We have here the summary of our lesson, no? Especially sa electron configuration, energy level, subshell present in each energy level, number of electrons per subshell, and total electrons per energy level, and the total orbital or sa orbital diagram kay boxes per subshell. First energy level, we have only S subshell, and per S subshell we have 2 electrons, and the total for the total electrons in each energy level is 2. And how many boxes do we have? Only 1. Second energy level, we have S and P subshell. Maximum electrons present nila is 2 and 6. So that makes 8. And half of it, or the boxes, is 4. Third energy level, we have SPD subshell, no? And maximum electrons per subshell, we have 2, 6, 10. And total electrons per energy level, which is the sum of these electrons, is 18. And boxes for the orbital diagram is 9. So on and so forth. So this is the illustration para mag-guided mo or dili mo makalimot. And that ends our lesson, last topic for this quarter.